Welcome to Summarize Science. Have you ever looked up at our moon and wondered if other planets out there have one just like it? Astronomers are especially interested in planets around M-dwarfs or red dwarfs because they are the most common type of star in our galaxy. Many of these planets are in the habitable zone, where liquid water could exist, so a big question is, could these planets have large, stable moons? This paper, titled Tidally Torn, investigates that very question. Researchers created complex computer simulations to see what would happen to a Luna-like moon orbiting an Earth-like planet around different types of M-dwarf stars. They modeled the gravitational tug-of-war between the star, the planet, and the moon, including the effects of tides, over hundreds of millions of years. The results were dramatic and, for moon lovers, a bit grim. For planets orbiting cooler M-dwarfs, like M4-type stars, the simulations showed that any large moon would be lost in less than 10 million years. That's just a blink of an eye in cosmic terms, and likely not enough time for complex life to get started. Around slightly warmer M2 dwarfs, things weren't much better, with moons becoming unstable and flying off in under 100 million years. So, what's causing this? It's all about tides and distance. The habitable zones of these cool stars are very close to the star itself, which means the star's gravity is incredibly strong, constantly pulling on the planet-moon system. Tidal forces from the planet cause the moon to slowly spiral away from it over time. Eventually, the moon drifts out to a point where the star's powerful gravity can snatch it away, flinging it out of orbit. But there is one scenario where a moon might survive. For the warmest M-dwarfs, known as M0 type, the habitable zone is farther out. Here, the star's gravitational meddling is weaker, giving a moon a better chance. In the best-case scenario, a large planet at the very outer edge of this habitable zone, a moon could potentially survive for over 1 billion years. That's a significant amount of time, long enough for life to potentially begin its journey. So, let's recap the main points. The study suggests that large, stable moons are likely very rare in the habitable zones of the most common stars in the universe. For most M-dwarfs, moons get torn away from their planets on timescales that are too short for the development of life as we know it. The only real hope for long-lasting moons is around the warmest M-dwarfs, and even then, the conditions have to be just right. What does this all mean for the search for aliens? If a large moon is a key ingredient for a stable, life-bearing planet, then this finding suggests such planets may be far less common than we thought. It provides a potential piece of the puzzle for the Fermi Paradox. Perhaps one reason we haven't found anyone is that stable Earth-moon systems are exceedingly rare. For the future, this research gives us a reality check for what telescopes like the JWST might find. In fact, the paper points out that a planned JWST search for a moon around the M-dwarf planet TI 700d is unlikely to succeed based on these models. It tells us that if we want to find a true Earth twin with its own large moon, we may need to focus on stars more like our own sun. Thanks for watching Summarize Science.